All right. So good morning, everyone, and welcome to today's Fusion Friday. My name is Alex Alvarez, application engineer here at Cut Technologies. So happy Friday, everyone. Hopefully you've all been managing to stay safe. Hopefully we're all healthy, spending some quality time with loved ones, which might have some pros and cons there, but nonetheless, still get to spend time with them. So again, thank you guys for tuning in. Again, for today, what we're going to be talking about is the manufacturing extensions that are built into Fusion 360. So again, we'll talk a little bit about them, what's included, how do you access them, and then we'll actually do a little bit of a hands-on demonstration to show you guys how you can leverage some of these extensions for your everyday programming. So let's go ahead and get started. As always, if you guys have any questions, please feel free to leave them in the chat box or in the Q&A section, and then we'll answer them at the end of the webinar. Okay, so again, some quick objectives before we get started. We want to make sure that we hit all of these before the end of the webinar. So again, like I mentioned, what are manufacturing extensions? We'll be covering that in detail. Explaining to you guys what exactly is included, how Autodesk structures these extensions, and then how long are they available for, right? Again, we want to show the added value to the software. We want to show you guys how these can really ultimately make programming just much more efficient. They can provide a little bit more of verification for some that may not need it, or maybe some people that aren't just too familiar with programming. They do provide just some additional verification for you guys. And then as always, we are going to do a hands-on demo, so stay tuned for that one. All right, so manufacturing extensions, really at its core, they're really just productivity tools for manufacturing people, right? So again, what these do is they increase your programming and machining efficiency. Now, these extensions range anywhere from advanced toolpaths. So we've seen the steep and shallow toolpath. I'm sure that you guys are aware of the toolpath and, kind of probably seen a few videos here and there. But they also or these extensions also range from part verification. So again, you can test your model in the machine while it's still, in its essentially the fixture, or however you're fixturing your model. You can make sure that it's meeting specifications. Make sure that you don't have any anomaly on the surfaces, or making sure that you really hit those tight tolerances that you're really looking for. So again, we'll go ahead and demo some of these strategies. And again, these extensions are accessible to people who need them, right? Meaning that if these strategies are too advanced, or maybe you really don't see any fit for them, then that's okay. You're not obligated to pay for these. You're not obligated to purchase them. It's only for people who really want to take that next step and really want that machining efficiency and programming efficiency as well. So how do you access them? So these are only accessible for paid subscribers and educational subscribers, meaning that if you're on the hobbyist subscription or the startup subscription, you're not going to see these manufacturing extensions. Now, you do need to purchase them with cloud credits. And again, if you're not familiar with cloud credits, go ahead and just post that in the Q&A, and we can go ahead and reach out and explain to you what that entails. But they are going to be 125 credits per month. Now, this is it's not a recurring payment, so meaning that it's not automatically going to reload, or it's not going to recharge every month. You do have to automatically click on that extension at the top and then access them for an additional month. So again, it's 125 credits per month. And like I said, it's a manual process. So each month that it's over, you do have to go in and make sure that you purchase them again if you still need them. So again, we got some of the miscellaneous items kind of here out of the way. Let's go ahead and dive into the software, see exactly what these manufacturing extensions look like. So again, this is going to be Fusion 360. If you're not familiar with the software, this is your first time kind of seeing the environment. Again, Autodesk has made a few changes to the tool tab and the ribbon up here. So again, it's a little bit easier to lay out, easier on the eyes. Again, starting off with your traditional sketching tools, your extrusions, your cuts. Obviously, you can do assemblies, and some of the construction geometry in here as well. Again, you can do surface modeling, you can do freeform modeling. So you really have a broad spectrum of different tools that you can leverage inside of the software. Now, not only that, but if you hit the drop down here, you also have different environments that you can jump into, right? So one of the biggest ones here being generative design, which we have a few webinars already on our YouTube channel. Go ahead and feel free to check those out. But you can do rendering, you can do animations, right? So your simulations. But the one that we're going to be focusing on today is going to be this manufacturing workspace. So again, as soon as I click on that manufacturing workspace, you see that our tool ribbon up here changes slightly, right? So now we have tools or commands that are going to be specific to the manufacturing workspace, meaning that we have our setup tab, we have our 2D and 3D strategies, drilling strategies, right? So our multi-axis, so any fourth or fifth axis. And then finally, we have our simulation tab. Again, how do you access these manufacturing extensions? Well, if you take a look up here, and again, if you're on a paid subscription or an educational subscription, you are going to see this available to you. But if you have those kind of subscriptions, you're going to see the extensions, and you're going to see, whether or not it's purchased or not. So right now, I do have it purchased, and in here, you're going to see a list of different technologies or different extensions that you can leverage once you purchase them. So the ones that we're going to be focusing on today, we're going to be doing a demonstration on the 5-axis and collision avoidance, hole recognition, steep and shallow strategy, and then probably my favorite to date is going to be this toolpath trimming. All right. So again, if you guys are coming from a higher end software such as PowerMill, you'll see that some of these strategies are actually from that specific software, right? So if you've watched videos or maybe you actually use PowerMill, the toolpath trimming capabilities in PowerMill, it's going to function exactly the same. So again, what Autodesk is doing here is they're trying to leverage some of the higher end softwares and just give little snippets or little breadcrumbs, if you will, of those higher end softwares into Fusion 360. Again, just added value for you guys. Again, making sure that Fusion 360 really is a all-in-one tool for both design and manufacturing. So again, with the first one that I mentioned, let's go ahead and talk a little bit about hole recognition. Now, again, if you're in the business of doing fixtures, or maybe you're doing R&D work, fixtures and jigs are going to be probably one of the biggest things that you might come across. So what a lot of companies do, or what a lot of machine shops do, is they'll actually create these huge fixture plates where they can essentially drill holes. They can either tap specific holes in specific configurations, and then they can start bolting down their parts, either for work holding, or maybe you want to do part verification with some of these fixture plates. But again, point being that these plates have just a lot of drilled holes and tapped holes. So again, the drilling strategy inside of Fusion 360 wasn't too hard to deal with. To begin with, it recognized the holes. You can specify a diameter range, but it was still a very repetitive process, right? So you still had to select a spot drill. You still had to select a drill. If it was tap, you had to select a tap. Now, obviously, you can create templates from those toolpaths, but you still had to select the holes, and there was still some manual process there. So again, with the manufacturing extension now, what we can do is we can go straight into the drilling tab. And again, this is a paid extension. So if you guys don't see that, it's because it's a manufacturing extension. But you'll see now that we have hole recognition. And again, just like everything else, if you're not too familiar with it, just hover your mouse over it. And it's going to give you a nice image here and as well as a good description kind of explaining to you what it does. Now, one thing to note is that this plate, I'm only working in the Z-axis, or I only have holes that are aligned to the Z-axis. You'll see in the diagram, though, that the hole recognition tool actually picks up holes in multiple axes, right? So it's not just going to pick up holes that are linear or collinear to your axis or coaxial. It's also going to pick up the hole, any holes on the side, right, or on different angles of your part. So again, it's a pretty drastic change, and again, something that required a lot of manual process in the before steps now is somewhat of more of an automatic step here. So let's go through it. We're going to go ahead and run hole recognition. Again, before we actually run that though, this part, I brought it in from GraphCAD. Again, if I need something on the fly, I usually just look for something on the web. So I didn't model this inside of Fusion 360, and you can probably see that if I go to the design, there's really no design history there. But you'll see that we have a few holes. We have a few tapped holes here as well, and as well as a few pockets. So these pockets, it's not going to pick up, but the rest of the holes, I'm going to be pretty certain here that it's going to pick it up, right? So we'll go to the hole recognition. As soon as we launch that, notice that it automatically categorizes the different hole groups that we have, right? So we have 1/4 inch holes, we have 0.3755 holes here, 0.159 hole, and it looks like it's the single hole we got on the side. And then it picked up these holes here as well, right? So these 4 holes, and it picked up that they were tapped holes or they were threaded holes. And not only that, it actually also picked up the thread type, right? So again, it's a huge deal here because again, the software is automatically picking up exactly what holes you want to machine. Let's say we don't want to machine that single hole by itself. Notice that we have an action tab. And in here, it's saying that right now it's going to apply a spot drill and a drilling operation to it. I'm going to go ahead and hit the drop down here and say, go ahead and ignore that hole. You'll notice that when you hit the drop down, you have different options, right? So you can spot drill and bore. If it was going to be a pretty tight tolerance hole, you can go ahead and use a ream instead, or a reamer. And make sure that you hit those tight tolerances. But for this one, I'm going to go ahead and say spot drill, and then tap the hole. And then for the rest, go ahead and do a spot drill and drill, and then do the same thing for these as well. You can go to the tool libraries. So again, another pretty big aspect here is that you're not just limited to working with tools in a specific or in a single library. You can select a specific tool library that you want to select from, or that if you have a specific material that you're machining, or maybe a specific machine that you're going to run this part on. Go ahead and separate those tool libraries by those different categories. And then select which tool library you want to pick tools from. Right. So again, some great functionality here that's built in. And then again, some more just miscellaneous options here. So do you want to find by angle? Do you want to only make sure that you only find specific diameter ranges inside of this part? You can go ahead and specify that here. But anyways, as soon as we click OK, we'll expand this. Oops. Okay, so again, it is going to take some time here to pick up the holes. And again, one thing that you do want to make sure of is that you have those tools available in the libraries that you select. Otherwise, it's not going to be able to apply those selections for you, right? So again, just one thing to caution: you do want to make sure that you have those different options enabled, right? And here you can see, based off of some of the user inputs that you can select. It does make sure that you drill through. Again, if you spot drill, you can specify some of those parameters in there as well. Again, for the spot drill, you can even take care of the chamfer. So if you had, these holes had some sort of chamfer, you can go ahead and take care of those as well. But again, a couple clicks and that took care of all the different operations that I needed. Again, the software is automatically it's automatically organizing these based off of the hole efficiency, or the toolpath efficiency. So whatever it sees fit, it's going to try to apply, that toolpath. It's also going to try to limit any tool changes as well. So just one thing to also note as well. So again, that was the whole the automatic hole recognition extension. So again, pretty straightforward. Not much to the not much to the tool, but again, it has some pretty powerful capabilities built into it. So let's move on to the next one. Let's go ahead and talk a little bit about the drill core. Again, so this is a model that, that I found online again too. Again, I have a 3D adaptive strategy here. We can go ahead and take a look at it. So again, this is going to be our roughing strategy. I'm going to simulate, turn the stock on here. Probably just run it for a little bit and then go to the end of the toolpath, right? So again, it's a roughing strategy. Again, it was my initial roughing strategy, so I could probably increase this a little bit just so I don't have, just the kind of these fine step downs. Again, if I was personally doing this, I would probably add one more, maybe even 3 different rest machining strategies just to make sure that I don't have as much material when I'm doing the finishing strategy. But for this one, just the time constraints, I'm going to go straight into the finishing strategy, right? And so what I'm going to be using for this one is actually going to be a steep and shallow toolpath. And again, I have a previous video or a previous recording where I talked about surface finishing, right? And again, a lot of what I talked about there was the different toolpaths that I would use would probably be a contour toolpath, maybe a scallop toolpath, parallel toolpath, just to get that nice surface finish. And depending on the models, you might also have to combine multiple toolpaths. Right? So you might have to range a contour toolpath from, let's say 30 degrees and up, and then the parallel toolpath being able to cover, or the scallop toolpath being able to cover the rest of that, right? Or from 0 to 30. So again, what the steep and shallow toolpath does is it actually combines those 2 toolpaths for us. Again, if you just leave the mouse here a little bit. So the threshold angle determines the boundary between steep and shallow areas. Again, passes in steep areas and shallow areas can overlap the distance. So again, it covers all of the different topics that I actually talked about in that webinar. So again, we wanted to make sure that we had some sort of an overlap boundary just so that we don't leave any witness marks on the model, especially if you're working on a tool or some sort of a die. You want to make sure that you don't have some of those blemishes. So let's take a look at the steep and shallow. And again, if we take a look at it, it's going to be just like any ordinary toolpath. So you really don't see much change here. The only additional change that you'll see in this toolpath is going to be this tool axis tab. And I'll talk a little bit about that tab here in just a second. But again, for the most part, everything here is going to be exactly the same to what we're used to. All right. So again, I have some predefined steps here, some predefined information just to make sure that we just get to the main points here. But again, if we take a look at the toolpath, I'm going to go ahead and say, okay. Here's the toolpath here. Again, I can probably do a little bit better job. And personally, if I was working on this model, I would actually make a few modifications. And one of those modifications would be getting rid of these little slots, either by doing some sort of surfacing strategies, using the surfacing tool in the design workspace, or just completely getting rid of them using the direct edit modeling capabilities inside of here, right? Because again, we don't want the toolpath to read any of these slots or these ribs. So I actually did do some surfacing for this, and again, you can kind of see if I hover over some of these. There are some patch surfaces for them. But again, it's still going to do some sort of reading, right? So for this one, I would probably want to have just a continuous fillet all along this wall here. So again, there's a lot more work that you can do. Again, so you're not just limited to programming what's on this part. You can actually go in and make some of those modifications. So again, this is actually going to be a completed one. Let's go ahead and apply a steep and shallow toolpath real quick here. So we'll go ahead and apply that toolpath. We'll use that 3/8 inch ball rando. For the machining boundary, again, I just want to focus on this model here. So I'm going to go ahead and say selection, and I actually want this portion. Right, notice that sometimes, again, the selection is going to be a little difficult for you to select. But again, if you hover over the correct edge, you want to make sure that you select the boundary that gives you essentially the best selection here, the best boundary. Again, you're not limited to working with whatever the software gives you. You can actually modify this. So let's say you want to include this face here. Right, and so what we can do here is, again, and I've talked about this when using previous 3D toolpaths, you want to take it easy on some of the options, right? So don't go straight away and changing all the different options. Give yourself a little bit of a break here and just select the boundary, go ahead and click OK, and see what the toolpath gives you. Again, the software does a pretty good job of calculating some of these toolpaths fairly quickly. So again, steep and shallow is a little bit more of an advanced toolpath, so it is going to take slightly longer. But nonetheless, compared to what other softwares are doing, it still does a pretty good job of generating toolpaths. So we'll give it a moment here. And again, you can hover over the toolpath and it's going to give you exactly, what percentage it's at for the toolpath calculation. So you need to do that. Or if you go to the Manage tab, we also have the Task Manager here, and it'll give you the same exact details. So again, there's a lot going on with this, and again, some added functionality. Maybe you guys are aware, maybe you guys aren't aware. If you turn on the little eye icon right next to it, it's actually going to show you, or it's going to lock that toolpath in place, and you can see exactly what that looks like, right? So again, instead of having to click on the toolpath and just having it visible for just until you click away, click on the eye icon and it's actually going to lock it in place. Some additional value here, or another kind of quick tip, if you don't want to see the leads and the links, go ahead and change them down here. Yeah, so you have a show, hide, leads and links. Sometimes there's a lot of noise kind of going on here, so it just makes things a little bit easier when working with it. So I'm going to go ahead and actually click on it just to see it a lot better. And you'll see what it does, right? So again, the toolpath for the steeper areas, it's going to try to do what we call a contour toolpath, right? So it's going to try to follow the surfacing here. What's nice about this too is that the software is actually aware of the surfaces. So depending on what kind of surface you're machining or what kind of surface it's going to apply that toolpath to, it's going to take that into consideration and provide the most efficient direction. So again, you can see the overlap here. It's kind of hard to see, but you can kind of see that there's some sort of an overlap between the contour or the steeper areas, and then the scallop toolpath. Again, this isn't a do-all toolpath, so you do want to make sure that you limit this toolpath to only specific areas. You'll see here that there's quite a bit of an overlap here, so we might want to go ahead and change that. Right? Again, we have these surfaces, but again, we have the patch surfaces already taking care of that. So let's go ahead and go into the details just a little bit more here. So we took a look at the geometry. That looks fine. Again, I would probably go ahead and do, just the model override and then select my bodies or the patch surfaces there. And then for the passes tab, so again, this is going to be where most of the settings and the fine tuning takes place. Again, starting off with the threshold angle. Again, so what angle do you want to specify what's going to be a steep and what's going to be a shallow area, right? So again, you can either set that at 30. I personally keep it at 45 just to start off and see what that gives me. The overlap distance. Again, you don't want to have a huge overlap, but you also don't want to have a small overlap or too small of an overlap where the tool isn't going to clean and leave that witness mark. Again, do you want to prioritize going top first or maybe the steeper areas first? So again, you can start seeing that there's a little bit more flexibility here in customizing or modifying this toolpath. Again, for the steep areas, do you want it to be a continuous toolpath? And again, if you're not sure what that does, hover over it. And really what this does is it just applies a spiral type toolpath. And again, you can kind of see it on the right-hand side. Right? So instead of lifting up, it's going to be more of a continuous toolpath all the way down. Again, sometimes depending on the geometry that you're working with, sometimes continuous might be the best option, and sometimes it might not. Direction, you can do climb cutting, you can do conventional, or you can do both ways here as well. Step down, right? So we're all familiar with step down here. For the shallow passes, and again, this is something that you have to take take aware of, right? So what kind of geometry are you working with? Is the geometry going to be best suited for a scallop toolpath? Or is the geometry type going to be best suited for a parallel toolpath? So again, it's really up to you guys, and it's really dependent on what kind of geometry you're machining. Again, you have the continuous option, climb, step down, and then the smooth offsets, right? So these two we get quite a lot of comments on. And again, with smooth offsets, and I'll probably go ahead and close that dialog box. But what you'll see here is that this toolpath actually has a couple sharp edges, right? So it has a couple sharp edges here, sharp edge there. So again, what the smooth offset does is it actually rounds off those edges, or it modifies the toolpath slightly so that it doesn't have essentially those sharp intersections. Again, with those sharp intersections, the machine is going to slow down quite a bit, just to make sure that it matches that toolpath. And it's going to start leaving small little cuts when you get to that section. So again, with the smooth offsets, the software actually modifies that. It modifies the toolpath slightly. It doesn't do a dramatic change, but it does change it slightly. And then it rounds this off just so you have a more continuous and a smoother transition. So again, that's just another option that you can go ahead and enable there. And then the last one here that I want to talk about is the remove cut junctions. And that's actually the same area, same exact area that we're talking about, but instead of rounding it, it's actually going to do a transition line all across those sections. Right? And again, I have a completed toolpath here just so that we can see exactly what it's doing. You can see that during these transitions, you'll see the toolpath actually has a small transition going on to the next offset toolpath there. And again, this toolpath, what I would do is probably modify this a little bit just so that we don't have any toolpaths in this area or in this region. And then to take care of the bottom portion, I'd probably do just a strict contour toolpath, right, to take care of some of these steeper areas. So now talking about some toolpath modifications. Right? So what do we do about some of these areas? So up to this point, what a lot of Fusion 360 users had to go through was either create sketches, create surfaces, right, or create just additional boundaries that you wanted to limit the toolpath to. Again, what Autodesk has introduced now is the modify option, and you can actually do a toolpath trim. So let's go ahead and see what this looks like. A few areas that I might want to modify, probably want to modify this section here. So for this one, again, when you're looking at these toolpaths, you want to take a look at what makes the most sense. Does trimming this toolpath make the most sense, or does limiting and using a void surface make the most sense? And again, depends on what you're working with, and how easy it is to make some of those changes. For this one, I would probably do a void surface, just to limit, touching any of these areas here. But let's go ahead and delete this portion here, because this is quite a large chunk here that we can delete. So I'll go ahead and just go normal to that face, and then I'll go to modify, right? And then I'm going to go ahead and start just selecting multiple points here. Right? And then probably just select this here. Again, you want to make sure that you hit the little accept or the plus sign. And again, in here, pretty straightforward. What do you want to keep? Do you want to keep the outside boundary? Or do you want to keep everything inside of this boundary? For us, I'm going to keep everything outside of it. I'm going to go ahead and click OK. Toolpath goes away, but then it comes right back up. And you'll see that now the toolpath looks slightly different, right? So now there's a little pencil right next to it. And not only that, another great addition is that now the toolpath has a timeline of its own, right? So if you ever need to go back, or maybe you don't like that modification, you can either delete that trim here, or you can right click on that toolpath and say discard modifications. An interesting fact here is that, a lot of questions we get is, well, what if you make a change to the toolpath, maybe you change up the feeds and speeds, or maybe you change a specific parameter. Is that section going to come back on? And the answer to that is no. So I actually changed the feed parameters, and that specific section that was there, it automatically it was gone, right? So you don't need to worry about changing parameters and having to worry about that section coming back on. So the next one that we want to talk about is this little area here. And again, we're just going to go ahead and go into the modify tab. Just apply some sort of a polygon here. Accept that, keep outside boundary. And then it automatically deletes that, right? So again, it adds that second trim down here. So again, if you ever want to delete one of those, or maybe you want to delete both of them, you have the option to do so. So pretty neat functionality. Again, this tool is going to be extremely helpful for people that are working with some sort of complicated models, and you really need to fine tune the toolpath to give you exactly what you need. So again, up to this point, we've been limited to working with sketches or working with surface boundaries or surfaces, and now you have just an additional tool to kind of tackle some of these toolpath modifications. So again, that's the steep and shallow. The steep and shallow modifications, and then the toolpath editing capabilities here. Again, I mentioned that the steep and shallow tab, or the toolpath, has an additional tab in the dialog box. So let's go ahead and take a look at it. All right, so we're going to go to edit, and it's got this tool axis. So what this is it's essentially giving the software the ability to automatically create a 5-axis toolpath out of this 3-axis toolpath. So again, steep and shallow is found under the 3D tab. And again, up to this point, you have the contour toolpath, which has somewhat of some similar functionality. It doesn't have it to the extent that the steep and shallow does, but again, the goal here for Autodesk is to ultimately give this functionality to additional 3D toolpaths that you see here. So again, for now, only the steep and shallow have the has the tool axis tab as of right now. So you'll see that the primary mode is vertical, and again, that if you leave it at that point, it's just going to be just a straightforward 3-axis toolpath. You do have additional options, so you can do a lead and lean. You can do from point, you can do 2-point, from curve, or to curve. And again, that's only if you want to, if you know more or less what kind of motion you want. Now, again, reason why maybe I would want to enable the tool axis capabilities here is for avoidance collision, right, or collision avoidance. So if I take a look at this toolpath, I'm going to just do a quick simulation here. Turn off the stock. I'm going to take a look at it from this view. Okay, so it looks fine. Again, it's turning red because I don't have any roughing strategies before that, so it's thinking that it's going to collide into the stock. But again, first off, it's machining this portion here, right? Which again, we can go ahead and take care of that with the toolpath trimming. So it's doing that. That's okay. It doesn't look like it collided anywhere. But now it's coming up that surface, right? So it's coming up the surface. And again, you can kind of see exactly what's going to happen here. It's going to go, and it's going to try to reach that next surface. And then guess what? Well, this is going to go ahead and completely collide into that part. Now, again, a couple options. You can swap this out, change it for a longer tool. But again, if you have 5-axis capabilities, take advantage of that. Right? So you want to make sure that you leverage those capabilities. And not only that, get a tool that's going to be much more rigid than something that has a greater stick out length. So again, I went ahead and I modified it. Again, a little pencil shows up because that's indicating that I made a toolpath trim to it. So I trimmed out this section. And with this toolpath, what I did is I actually turned on automatic collision avoidance. Right? Well, I turned on collision avoidance, and then I set the avoidance mode to be automatic. So if you hit the drop down, you'll see that you have the same options, right? So you have from point to point, 2-point, from curve. I'll explain these in just a second here. If you're working with a complicated surface and you're not sure exactly what kind of motion you want or what kind of a collision avoidance you're looking for, just set it to automatic. Right? So let the tool do that by itself. You can take this one step further and turn on machine configuration so that the software knows exactly which axis to rotate or which axis it has available to play with. But again, that's a whole different story here. But for us, again, we're going to go ahead and set this to automatic. I'm going to take a look at the toolpath. Again, if I go ahead and run the simulation, notice that it's automatically coming in at an angle, right? So you can more or less see that it's using the lead and lean options, and it's applying that to the toolpath. And now if you take a look at the toolpath here, you'll see that it's doing the toolpath, and it's actually machining the part while avoiding any collisions, right? So again, this functionality, as of right now, it's only built into the deep and shallow. But again, this is a huge deal, right? Because again, up to this point, you either had to create some sort of axis that you wanted your tool to be pointing at, or you had to essentially figure out some sort of additional way to rotate the part or maybe fixture the part a different manner so that you can get to the specific area. Nice thing about this is that the tool it's not only locked in one axis. You'll see in a second here, it actually does start changing rotation. So this is a true simultaneous 5-axis toolpath here. Let me speed this up. So you see that there it transitioned back to a different tool axis. Right. So again, collision avoidance. Again, this is only built into the steep and shallow, and this is again used for if you want to have the tool automatically calculate the avoidance type for you guys. Now, again, in the option there, you saw a few different options that you can play with. So you can select from curve to curve, from point to point, right? So you have a few different options to select from. The from curve to curve and the from point to point, they work very similar. So I'm going to go ahead and focus on the from curve, and then the next model is going to be the from point. But essentially what this is doing is you as the user or you as a programmer is specifying some sort of geometry that you want the tool to follow. All right, so in this case, again, I'm working with the steep and shallow. I'm going to go ahead and select the tool axis. This time the tool axis is going to be from curve, right? So right off the bat what kind of motion you want this toolpath to have or this tool to have. So I'm going to go ahead and select from curve. I created a curve because I want the tool to essentially just follow that curve as it's machining this surface. And the difference between from curve and to curve, you'll see here in a second, but from curve actually it points the tooltip away from the curve, whereas to curve, it does the opposite, right? So it points the tooltip towards that specific curve that you have. Smoothing distance. So again, the greater the smoothing distance, the more gradual the transition. So again, this is a pretty small smoothing distance. So that means that the transition is going to be a little bit more abrupt. So you can go ahead and increase that maybe to 5 inches, right? So it's a relatively small part. Smoothing angle is you're essentially giving the angle that the tool is free to move. So it can change axis or it can change rotation anywhere from 0 to 5 degrees. And then anywhere past that, it's going to lock it in a specific angle or a specific direction. And then for this one, I'm going to go ahead and say OK. And again, steep and shallow toolpath is a little bit more advanced, but it does take just a little bit longer to generate. So just keep that in mind, right? So again, let's go ahead and simulate this just so we can see exactly what's going on. I'll turn the stock off for now, and then I'll go ahead and hit play. But if we take a look at it from the top view, you can see exactly what's happening, right? So it's locking the tool in a specific axis, and then it's just following a specific motion that we allowed it to. So again, it's from curve. So exactly like I mentioned before, the tooltip is going away from the curve, but it's still following or still maintaining on that specific curve that we gave it. right? So that's the from curve option. Let's go ahead and take a look at the from point option. Here's a steep and shallow toolpath. Again, this toolpath is just a 3-axis toolpath as of right now. If we go ahead and simulate this, right? So the axis, just a vertical axis, and it's just working its way down, stepping down into this model here. Right? So I'm going to close this. Let's go ahead and make this into a 5-axis toolpath. I'm going to go ahead and duplicate this steep and shallow. I'm going to edit the settings. And again, for anything that's either spherical or maybe even conical, the 2-point option is going to be a great strategy here. So again, we're going to go ahead and go to the tool axis, and we're going to say from point. I think I said 2-point. It's got to be from point. I'm going to go ahead and expand the model. And what I did is I'm just going to go ahead and reference a sketch that I used to create this model, right? So I'm going to go ahead and say from point. I know that I want this to be my guiding point. Moving distance, you probably increase this, right, which is 50 millimeters. Again, typically take a look at the settings, and like I said, don't try to change too many settings at one time. So just change a few settings, see what the toolpath looks like, and then, you know, if it's not what you're looking for, then go in and make those modifications. I'm not going to override the tilt angle, collision avoidance. I'm really not too concerned with any features here, so I'm just going to go and say OK. Again, generates a steep and shallow toolpath. I'm going to collapse some of these options. But again, it's going to generate that toolpath, and it's going to do it based off of a specific point that I selected, right? So no longer are we limiting to a curve, or the motion is no longer going to be trying to follow a curve. Now the toolpath is going to follow a specific point that I specified. And then you'll see here, right, what that looks like. Now, again, that point might be a little bit too low, so maybe we want something that's a little bit higher. But if we take a look at the top view and simulate this, you can see exactly what it's doing, right? So it locks this tool at a specific point, and then it goes all the way down until it tries to machine that entire surface. So again, I have both ways enabled in this one. You can go ahead and modify that. But again, with this one, you can see exactly what it's doing, right? So it's going in here, it locks the axis to a specific point, and then it tries to machine that surface as it's going down. So again, pretty straightforward webinar. Again, these additions were brought to you by the manufacturing extension. So again, if you guys have any more questions on manufacturing extensions, when you would use them, or if you just need help applying them to a specific part, let us know. Let us know in the Q&A here, and we can do, we can sit on the call and kind of walk you through some of these options. But again, for the price that you're paying for the software and kind of for the price that you get the manufacturing extensions, I think it's a huge added benefit to any user that would like access to these. So again, that's what I have for today. Again, if you guys have any questions, I can go ahead and answer them now. Let's see if we got any questions so far. Okay, so it looks like we have some questions about rotary and 4th axis. Does this extension help with the setup? So I'm not sure what you mean by helping with the setup, but yeah, so that was actually an addition to the manufacturing extensions, right? So again, if we take a look at the extensions, we see that we have a rotary strategy. So again, if you guys are familiar with different CAM softwares, they'll refer to this as a barrel strategy. But yeah, so this is essentially what this toolpath does is if you have a 4th axis, a 4th axis indexing machine, and you have the rotary capabilities, essentially what it does is you can lock one of the axes, right? And then it's going to rotate the model around in this case, let's say the x-axis, and then it's going to toolpath or create toolpaths on that specific model. So, and it looks like this question came from YouTube. So if you can go ahead and just leave your information, we can go ahead and sit on the call and discuss those details a little bit more. So the extension wouldn't help you necessarily with the setup. So the setup would be on your end. But it does create a toolpath for any 4th-axis machines that you have available. Even 5-axis, right? You can use this toolpath for a 5th-axis machine. Again, let's say we have a question from James. Can you use this with your startup subscription? So you can't use this the manufacturing extensions. Unfortunately, right now they're only available for paid subscriptions and educational subscriptions as well. All right, so give it a few more seconds here, see if any more questions come in. But again, guys, hopefully you picked up a thing or two. Fusion 360 is definitely taking kind of a leap, huge leaps ahead with some of these additions. A lot of questions I get is, well, why will they make these paid extensions? Again, to keep the price down and then to make sure that everyone gets exactly kind of what they want at a fair price. In order to keep that price down, they have to charge for some of the more advanced functionality. Again, maybe not everyone needs the maybe some of these advanced toolpaths or some of the probing strategies. So that's why they don't include it to your general subscription. But again, what that does is it keeps the price down, and then it only gives access to people who actually need or who are actually looking for these strategies. So again, guys, it doesn't look like we have any more questions. So with that, stay safe. Thanks for joining me, and we'll see you on the next one.